read it. Whether I inform you or not, it has to be done. Huh? In the notebook, in the textbook, I don't care. I'll do it. If you do it in the textbook because some of the questions are in the blanks and whatever, then you can use a pencil in your textbook. Otherwise, you do it in your exercise book. Have you done it?
Yes.
Have you done it? Have you done it? Why not? Because you want a thrashing. Because you want a thrashing. Shall I give you in front of everybody? Dada? Yes, worse than Bongo Babu. But Bongo was intelligent and he was decent man. This fellow is, I don't know what. A disgrace to the Lobo race. Your what? Dice, huh? But you came on the Lobo, no? Dice. Okay, now we come to chapter 2. Chemical changes and reactions. Anybody is absent here?
Yes, ma'am.
Who's absent? No, I didn't hear.
Who are absent? She's.
Who? Where is she? Where, he or she?
She.
Where was she sitting down here?
She's sitting right here. She's out of town.
I can't remember that word. Anyway, so we come to chapter 2. What is chapter 2 now? Chemical reactions and chemical changes. Okay. Now, first of all, look at me. Not in your book. What?
In this first chapter.
First of all, what is in your mouth? What is in your mouth? What are you eating in my classroom? I'll thrash you. If you're eating, you can give everybody to eat. She. What do you want, Benny?
Ma'am, there is a question. Our school teacher said that there is an algebraic method of solving the equation.
No, you do only trial and error method.
But
No, it cannot be given to you. Look at the portion, at the syllabus. Okay, look at the syllabus. All right. It is omitted. That is look at the. You only do the trial and error method. That is accepted. Okay. Yes, it's not in the syllabus. You show it to your teacher. Don't show it to your teacher. Don't show it to your teacher. Yeah, please don't do it. Don't show it to your teacher because she'll give you a slap. Okay, no teacher wants to be corrected. Understood? All right. So now we come to chemical changes and reactions. First of all, suppose we have a particular compound here. No, no, I want a pen. Marker pen. No. One minute. Marker Now, what happened is, suppose we have got, say, 2 compounds, okay? We have got now, say, sodium chloride plus silver nitrate gives you sodium nitrate plus silver Cl, silver chloride. Okay? Now, these you know are the reactants and these are the products. Correct? Now, when you are writing down a chemical formula of a compound, I told you the metal should come first, the non-metal should come after. That is the system. Metal first, non-metal. Metal first, non-metal, metal first, non-metal. Okay? Now, what is holding the metal and the non-metal together is a particular bond. Okay? It's a so you have actually it is NaCl. No, I want this one. NaCl. Then you have plus, okay, AgNO3. Okay. Then you have got NaNO3 plus you have got AgCl. Correct? In other words, when you have put these two together, what is happening? They're interacting with each other. What is happening in interaction? The bond is breaking. And how it's breaking? And when they break, you're getting Na free, Cl is free, then you're getting Ag free, okay, NO3 free. There's no bond. The bond is taken away. So these are freely moving and then they're able to connect. Okay, So this bond that we say is actually a force of attraction. It's not a thread that is tying you. Okay, like two of you, finally you have to imagine it. Like two of you are very friendly with each other. Okay, you can see that you're bonding. You know, you'll talk, you'll smile, you'll laugh, you'll go out together, whatever. We know that you are bonded. Can we see a thread tying both of you up? No, it's only a force of attraction. You'll attract. So similarly, just as there's a force of attraction, here also there's a force of attraction. And that force of attraction is keeping the metal and the non-metal close together. Correct? All right. Now, when they're interacting, that force is broken. The force is broken. And the radicals, or I would say, the elements are set free, and then they are able to combine metal with non-metal, metal with non-metal, and you get a new product. This is clear. This is what happens.
I am the bond between
Nitrogen and oxygen. No. This is a radical. It will work as a group. That's a molecule. It is a radical. It will not break up. Okay, that is held together. Okay, so ultimately, actually, there is also a little bit of a breaking up here. But yes, the bond is very, very strong. It remains as a radical. Okay, so therefore you have got this type of interaction and you're getting the products. So this is your chemical reaction, and this is what happens. And we say it's a chemical change because the product, the reactants, then became products which are differently new. Correct? Yes or no? Now, for a chemical reaction to take place, there are certain conditions. The best conditions that will help a chemical reaction to take place is when the reactants are in the liquid state. When they're in the liquid state. In solid form, no, not much. In liquid state, yes, the reaction is very, very fast. Correct? All right, that's one thing. Secondly, for interaction to take place, they have to come close to each other. Not far away. You can't interact with far away. They have to be in close contact. So they should be in close contact. Close contact. Okay? Close contact. All right? And thirdly, okay, if you're using solids, make sure that the solids are small pieces. For example, if you take a big lump of sugar, it will take so long to stir and stir. But if you have crushed that sugar into powder, it will dissolve very fast. So the particles have to be very, very small. Okay, so they should be mostly powdered. Tiny particles of the reactants. Correct? Okay. Now, usually, if it is a liquid, then there are no pressure particles. They're all dissolved. Right? Next one. Secondly, what you need is you need energy. You need energy. Now, energy will be in the form of heat. Heat. You have light, electricity. You have electricity. Okay. Then you have got. Then you need pressure. Then you need catalyst. Then you need a catalyst. Okay? Promoter comes here. Promoter comes here because it is an assistant to the catalyst. A promoter is an assistant to the catalyst. Okay? But I will come to it. Right now, these are the main headings. So, for heat, for any reaction to take place, you need heat. Okay? So, for example, give me one reaction with heat. Suppose you take now calcium carbonate, you need heat. It will break up into calcium oxide plus carbon dioxide. This is heat, huh? This is heat. Okay? All right?
CaCO3 is quick line, right?
CaCO3 is calcium carbonate. Quicklime is calcium hydroxide. Quicklime, that's different. Milk of lime, that's different. That's calcium hydroxide. So you got heat here, correct? Now next one is light. Light is your photosynthesis. Light is photosynthesis. So suppose you can take carbon dioxide plus what you've got here, water. What are you going to get now? This is light. Light means sunlight. Light means we will say sunlight. Okay? So what are you getting? Glucose, C6H12O6 plus you're getting oxygen that is liberated. Correct? You have to balance the equation. Is this clear? So that is with your light. Electricity. You need for electricity, you need, say for instance, you've got water. Water. On giving it electricity, this is the electricity. You're getting hydrogen plus you're getting oxygen. Okay? 2, 2. Correct? Electricity. Then you've got pressure. For pressure means, say for instance, you put pressure, and when you're putting pressure, mostly gases, when you put pressure, you're bringing the reactants closer and closer, and therefore you're helping them to react. Okay? So, ammonia. So you have got now for nitrogen plus hydrogen, okay, will give you, it's a reversible reaction, will give you an ammonia, and your pressure is about 200, at 200, a little more also sometimes, little more than between 200 and 300. Yeah, 250. That is temperature. Temperature. Talk about pressure. Talk about pressure.
There are all the examples in this Fe as from a
Yeah,
catalyst and
that is, yeah. In the case of all you get it there, okay? So you have got your, now you've got your electricity, you've got pressure, correct? Now finally we come to catalyst. What is a catalyst? As I explained to you last time, a catalyst is a particular element or perhaps a compound which will help to change the rate of the reaction. Why do I say change? If the reaction is going too very too fast, it will slow down that reaction. That is said to be a negative reaction or a retardant. And if you have to accelerate the reaction, it is said to be a positive catalyst or a accelerator. Okay. So therefore, now you have, say for instance, you've got KClO3, potassium chlorate, LO3. Okay. When you're using the MnO2, so you're going to get KCl plus you're going to get oxygen. Okay. KCl plus oxygen. Now, MnO2 is a positive catalyst. In the case of ammonia, if you have to use ammonia plus H2, you have got your Fe and molybdenum. Now, Fe is the catalyst. But what has happened with ammonia? Look at it carefully. This is what now? So getting NH3, N2, 2N, and 3 2s are 6. 2 3s are 6. Now this is 1 plus 3, which is equal to 4. 4 volume. 1 volume plus 3 volumes is 4. And here you're getting only 2 volumes. Here this is 4 volumes. You are using 4 volumes of your reactants and you're getting only 2 volumes. So this is a very peculiar type of a reaction. Okay. For such type of reaction, you need very high temperature. Okay. When you have a particular reaction where the reactants, the quantity or the volume of the reactants is more and the product is much less, then you have to adjust the factors that you need for the reaction to take place. So first thing is you adjust the temperature. So you increase the temperature. If you increase the temperature, the entire plant can burst. So therefore, an optimum temperature is used. 150 to 200 degrees centigrade. Optimum temperature. So things are bringing that. You're bringing down the temperature. Okay, it needs high temperature, but you're bringing it down because you want to save your plant. Correct? Also, it needs very high pressure. Okay, again, when 800 atmosphere, high temperature, high pressure again will burst the plant. So you bring down the temperature to 200 degrees centigrade. Okay, so if you brought down the temperature and if you brought down the pressure, automatically the product will be very slow. So we are adding a catalyst. But this catalyst is not able to work efficiently. In order to make it work efficiently, we are using molybdenum, which is a promoter, which is assisting the catalyst to react or to work to its best efficiency. Okay, so that is how we made a promoter. What is a promoter? A promoter is a help to the catalyst when the catalyst is working under very extreme conditions. Right? So this is the promoter. So now have you got it? So here we have also a promoter. And the catalyst here got the promoter. Okay, so now you got now all these factors. Alright. Now, what happened?
Our teacher told that one wind or either wind or sound wind is there for particular.
I didn't hear you.
Either wind or sound, one of them is for one.
Where did you check?
For one zinc something.
It's on the next page. Sound.
Sound.
Acetylene का breakup.
But that's not a very main factor. It's very for very rare reactions. It is not a very common factor. Okay? Wind means pressure. Wind will come in under pressure. But when talking of sound, yes, sound is also required. But of course, it is for very rare reactions. Okay? You're talking about nuclear reaction, which is not in your course.
Ma'am,
Okay? So leave it.
sound energy as in like which sound?
Noise.
Like which kind of?
Only
Right, not like that.
That was
Which kind of?
High pitch, low pitch.
high pitch, low pitch, whatever it is, it could be depends upon what are the contents and how sensitive those contents are to the vibration or the frequency of the sound.
Like this.
Now, when it is an enclosed container and then you give them the sound, you're sending vibrations. It's a vibration that creates the, I don't know. That part of it I'm not able to explain to you because I won't tell you, overall, that it sends in vibration. With the vibrations, you're sending the reactants into motion and the molecules react with each other. Is this clear, all of you? Now, how do you know that a reaction has taken place? How do you know that a reaction has taken place? First of all,
When some
Change of color.
no, okay, forget about it. First of all, you go to touch the container. You find heat. Heat is given out. So first, where do I write it down now?
rub the mold.
Okay. Upper portion I wrote. No? Okay. So how do you know that a reaction has taken place? So the first thing is you will see that there is a heat is liberated. When you touch it, it needn't be very hot. It can be warm, touchable. Okay. Sometimes it is very hot also. For example, I'll tell you. So first of all, heat is liberated. Heat is evolved. Now we have got say calcium oxide. This is lime. Now calcium oxide is lime. Now what lime is this? This is that white chuna. Now what is chuna? I'll tell you. It is not nimbu, huh? This is not nimbu. Huh?
That they put on
Ha! On the road when you go, just look down on the road and you find little plastic bottles with green cover or blue cover thrown on the road. That these people take and they put on their palm and they eat it. It's edible. That's edible. Or they put it on the leaf. They put on the leaf and they put their tobacco and they eat it. Don't try. Understood? So this fellow will do anything. So that is said to be this calcium oxide. That is edible. But this what they are using in the chemistry laboratory is not edible. Now when you take this and you add it to water, plenty you get calcium hydroxide. Now this is your quicklime. Now quicklime or milk of lime, or slate lime. Now all these are commercial names for this particular product. Why is it called quicklime? Because very quickly this is dissolving in this quickly. Okay. Why is it called milk of lime? Because it's white in color.
From that heat
Huh?
water.
Huh?
That's the material that
I tell you, just listen, keep your mouth shut, for heaven's sake. And slate climb, of course, is just a general name for it. Okay, nothing peculiar about it. Now, I'll tell you how it is. I don't know whether you'll have observed it because most of the time you people are on your mobile or on your computer. You don't bother to go and look out and see the natural things that are happening, on the road. Now, especially these government offices, they will take this lime, that is calcium oxide. They're big, boulders, big boulders of white compound, calcium oxide. And listen to me, there's a bucket or there's a big tub of water. They will throw it into that water. Why?
All the whole
That big thing, they will just throw it. Why? Because they put it inside. Why they have to throw it? Why they stand here and throw it there? Because they're playing throw ball.
just to
And
reaction.
because it dissolves so very, very fast, and the water will start boiling and fall on their faces. A lot of heat given out, so much of it. So they will put as much as they want, and with very long bamboo sticks, they will stir it and stir it and stir it till it all dissolves. Now, these are calcium salts. Calcium salts are not completely soluble. Are not completely soluble, okay? So you will find it's all milky and it is very opaque. It's not transparent, okay? And they will leave it like that and go away for 3 days. The area around is so very hot. It will take about 3-4 days for the temperature to come down to room temperature where they can easily approach it. So every day they'll come, they'll stir it morning, noon, and night. Okay, they'll stir it till the temperature comes down and till the whole thing becomes white. Then what do they do with that? The calcium they will take and they will apply as tuna. You know this tuna paint that they put on the government walls, all government buildings, cheap houses, cheap offices are all, the walls are all painted with this calcium hydroxide, with this tuna. Okay, why? Because this tuna is got antiseptic properties. It keeps away insects, keeps away white ants. Okay, all right. And then initially when you put on the wall is blue in color, light blue in color. As that water keeps on drying up, the calcium hydroxide combines with the carbon dioxide of the air and forms calcium carbonate. Calcium carbonate is marble, it's pure white. After some time, 2-3 days, the full blue will disappear and the walls appear to be white. Okay, that is your heat.
so that the blue color is only for 2 to 3 days.
Only for one, until the water dries up. Until the water dries up, the color is light blue. Afterwards, as the water is drying up, okay, the calcium hydroxide is combining with the carbon dioxide of the atmosphere and forming calcium carbonate. Calcium carbonate is marble, white color. The walls become nice and shining and white. Okay, now, so first thing is heat. The second thing that you observe when your chemical reaction is taking place is change of color. As you say, color is changing. Change of color. You say color. Change of color. See what happens is, suppose you're taking now blue copper sulfate, okay? This is blue in color. And you're adding Fe to it. Fe to it, iron. Filings, iron, they're not iron blocks, huh? Iron filings. You add it, what happens is iron will displace copper and you're getting FeSO4 plus you're getting copper precipitate. This is becoming greenish in color. Green in color. So from blue it has become green in color. Change of color. Correct? Then also you have a PPT formed. Correct? You have a PPT formed. Sometimes what happens is you have gas evolved. Okay? So you have got change of color, heat, PPT formed, then you have gas evolved. Okay, now gas evolved is, as you say, effervescence. How do you come to know? In the case, yes, carbon dioxide is given out, this is effervescence. When you open up the soda bottle, all bubbles are coming out, that is carbon dioxide coming out. Now, what is the difference between the bubbles coming out from this bottle and the bubbles coming out from the water that is boiling on your stove? Both of them are giving out bubbles, no? This is at room temperature, correct? This is at room temperature, ordinary temperature. This is boiling. That is boiling water giving out bubbles. This is ordinary. That means the gas was locked up inside. Okay? And this is boiling. Alright? That is the difference between boiling and effervescence. Okay? What else? What are the different things that you notice? PPT is formed, heat is given out. Energy is heat, no, Baba. Energy is heat, huh? Huh?
Change in state.
Change in state. Now, for example, is now, for example, yeah, you can say now, if you say change in state, suppose you have taken, you take a particular, you have taken, say, ammonia, plus you're taking HCl. Now, ammonia is a gas, and this is a liquid, okay? Liquid. what you're going to get? Solid ammonium chloride. Solid. Okay, solid ammonium chloride. Ammonia is a gas. HCl is a liquid. And when you combine together, you're getting a solid. So they always come. They give write down an equation where you have all the different types of matter present. So you have gas, you have liquid, and you have solid. HCl, ammonia, and ammonium chloride. Okay. I finished up what I want to teach you today. I will now read and do in-text question. Just now, stop sitting down there and do the sleep. Understood? Is my voice sounding like a lullaby to you? Huh? Feeling sleepy? Lullaby. Lori, Lori. Clara. Learning chemistry in a very relaxed manner. Foolish fool. Now, tomorrow I have to start take English. Now I've got 2 hours with you. I finish with Bonko Babu. I give you that one particular question. I want that answer. You don't bring that answer, I'll fling you out in the middle of the road. Remember that. Okay, that's tomorrow, not today. Huh?
I'm not.
Good. Stay at home, and if you come afterwards, I'll throw you out.
I'm not staying.
Huh?
I'm going home.
Go to hell. I mean, what out? Go to hell. I can show you the shortcut to go to hell. What are going to go out? Go to hell.
We have completed.
Now, you've not taken English, no? You've taken English. Actually, listen to me. So tomorrow 2 hours, no? So what poems have you? I'll do tomorrow poems. Which poem has been done? 1 hour, 1 poem. I remember, I'll do that one poem. Is that the poem? Okay, very good. So these 2 poems I'll do tomorrow. Okay? Work of artifice and treasure test you bring. You bring your volume.
English. No, we didn't get it.
ICSE volume. Ask Vijay.
They say
Go
it
on.
has not come.
Not yet come. When did you ask?
But Hindi.
Last time.
When he received
No, ask him again. So go and ask him. In the meantime, you'll read. Come on, hurry up. Read! Huh? In text questions are there, no? In text questions are there until this particular chapter where I've taught you. Don't go beyond. Don't go to types of chemical reaction. Don't go there. Just go to what is a chemical reaction, what are the conditions, and how do you know the chemical reaction is taking place. So that much. What I taught you today, that only you do. अभी तक आया ना कभी आएगा नेक्स्ट ईयर आएगा क्या पता नहीं चलो come on. I will all follow what I explained to you just now. And have you done this in this class, in the school? You have done it?
They're not completed.
No, but up to this, you have done it. Okay. So you're from Jaipur, yeah? Who's from Jaipur? You're from Avalon. Not Point. You're from North Point. You're not from. And his boy? Oh, sorry. Podar. Gold Crest.
When we will do the language part.
Huh?
When we will do the language part.
Let me do this. And next week I will start. Language means what have they done in language now?
Formal, informal, notice, email.
Email notice. Okay. Huh? Everything. One lecture only should be everything for you.
She said it's functional grammar. That's
Pardon me?
She said it's functional grammar. That's it, the question. And then the informal.
Sometimes for preposition, the next second is adjective same.
Active and passive preposition.
Not in the same lecture, no?
On the same lecture.
Same time only. No, we'll do it differently. I'll take 1 hour for you. I'll give you exercise.
Formal, informal letter, email, notice, and question.
Email and notice I will take 1 day.
Ma'am, essay writing and
Narrative essay.
short story.
Okay. We'll take 1 hour for every topic. I have the whole year
Story.
to teach you.
Story.
Huh?
Where can you buy calcium oxide?
Pardon me?
From where can you buy calcium oxide?
From where do I get calcium oxide? Why do you want calcium oxide? Why you want? Why? Tell me why.
Go to a pawn shop and ask.
Not pan, no. That is very, you can go to the pan shop and tell bottle.
Why do you want
This is small, this is small bottle.
They already say a lot.
Huh? You have to go to
Ma'am,
Dawa
is
market
that
and get
healthy
Dawa
for
market.
us?
Or the,
Ma'am, is that healthy for us?
huh?
Is that healthy for us?
Of course not. What you talking?
Is it worse than
Ma'am, he
tobacco?
said he is healthy for us.
No, what they do is this calcium, this tuna, no? You know, when you have these bananas, no? The whole bunch of bananas, they cut it up and it's raw. The banana is very raw. So if they have to artificially ripen it, they take every red, they will put one drop. By the next day, the bananas become yellow because of the heat. The heat is so much that immediately heat.
Yes,
What we do in the village, or what your grandmother will do in the village, she'll take it out and she'll wrap it up with some sackcloth, or she'll wrap it up with some straw, or she, with whatever, she'll wrap it up in a very, what you say, organic manner. She will do it. These people who want to get quick money, they will ripen it by adding this calcium oxide,
Nowadays,
and
yeah,
it'll ripen. It'll ripen. But the taste of naturally ripened and artificially ripened is very, very different.
But then that drops will be absorbed in the feed.
Yes, yes, yes. Why do you think every certain person today is suffering from cancer? Why do you think more of chemicals is being ingested than rich, healthy, fresh food? In the village, they are eating fresh food from the fields, and their fields are all the time manured by cow dung, not by chemical fertilizer. They don't have the money to buy chemical fertilizer. Their dry leaves, all the old leaves, etc., all into the soil or cow dung, organic. And the food is very different. The taste is also very different, and they are very healthy. They're very healthy. Those people.
Nowadays there are like chemical like ripening pouches in the mango boxes.
Yeah. So that is called calcium.
Something
Calcium carbide.
ammonia. It was
Calcium
something
carbide.
ammonia. Calcium carbide.
It's calcium carbide, or you have got ammonium phosphate.
Yeah, ammonium phosphate.
That is a fertilizer. That is a fertilizer. It is,
And there was a
it is-
pouch in my
Yeah.
mango box.
She
Like ammonia, it was written something ammonia. I didn't remember.
ammonium phosphate. It is also a what's the
Ripening.
artificial ripener.
Tuna in weddings.
Tuna, very.
And once they apply
For what they could apply tuna? Where?
tuna.
Either.
Teeth.
Where they apply?
Like if someone fools you, we say like tuna lagaiya.
Tuna. That means you have whitewashed it. That is called whitewashing. That is telling a lie and ullu banaya. That's a different thing.
Tuna lagaiya.
Tuna lagaya. That is not. No, this is not. That is good thing. That is good thing. Shall we read now? Enough of entertainment.
Ma'am, can I mark the answers?
Huh?
Can I mark
You can mark it with pencil.
the pencil?
And no, you're talking about marking wrong answers. No.
Wrong?
I'll tell you one thing. If it is small questions, meaning fill in the blanks or match the columns, that you can do in your book. When it comes to long answers or even short answers, I want you to answer bullet form.
Only bullet.
Yes.
Paragraph.
No, not necessarily. I don't want to see paragraph. You don't write paragraph writing in chemistry. In English, no bullet form. If you write bullet form in English, I tear you up and tear your book and tear everything up.
There is a question.
Only in chemistry.
So we can just mark
Bullet,
it
bullet,
that
bullet,
first point,
bullet.
second point.
Huh?
We need to write now.
We have to
Why?
write in a note.
Your fingers are dissolving if you write. Huh?
It's like
When you write, you practice your writing, you practice your speed also. That is why we ask you to write. How you get one? Thanks. Good blister readers. Blisters, big blisters, big. And you already got blisters when you were small. When back fell on your hand. Do you remember? When we went for one party. Huh? No, it's joking. But it's all the flesh is all cooked. It's cooked. That one. You eat the skin, eat your finger, try, no? Try, you finish your plate. Try, who's stopping you? Eh? क्या है? हरी है?
The tuna water is going to burn your skin, then bite. Doesn't it burn the stomach and the.
He's talking about slake lime, not dry. What you're putting on is dry. When you put more, don't do the reaction will start.
What if.
In fact, there is water in your body also.
Yeah, so the acids in the body.
Like, so if you see those people's palms, they are very rough like leather. And you touch those hands, so touching man's hands. But but their palms are very rough, very rough. So they are, yeah, very rough, very rough. It's like leather.
I was asking, what if the people who eat these all, do they feel warmth in their mouth?
And does it dissolve the mucus in the
Even
stomach?
put fire on the fire.
What happens inside, whatever is dangerous, it's damaging. And you find that people, some of them having,
Damaged teeth.
No, even damaged teeth, yeah, the mouth, cancer of the mouth. Cancer of the mouth. Read. How much have you read? Which book have you using? Your Potter, no? Potter has got Selena, why are you using Dalal? Huh?
No.
You're using Dalal? Andrew used to bring Potter, this thing, Selena. Who else is in Potter? You are in Potter, no? You're Selena, you are in this thing. You got what number you got? Dalal only. Okay. Read properly. Hurry up. If you want to follow properly, follow from here. What happened? Read from here. Okay. Hurry up. Start writing down the answers, quick. Read and then answer.
Here's a question, like you have to write an example of a reaction. Can we write it in the book?
No. Which part of my sentence you not understood?
So the homework will be you have to complete it. You have to complete it.
Yes, they are.
This or
Just read it.
we have a practical in which I have to represent a reaction where the reaction should be exothermic. So what a reaction should be? This one. I thought you would potassium and water. It will write it. What's that?
Try sodium instead.
So sodium is not more than your hand, right? It gets higher. It gets higher. So you
Like
get higher.
we have to do like we can just cut it fast from the kerosene on.
Are you going mad? Are you going mad? The teacher will not give it to you. Then it catches fire immediately. That's why it's kept in kerosene.
And the moisture.
Come on. It's not even kept in water because water has got oxygen. It will catch, react with oxygen of the water and catch fire.
Like sodium kaboom.
Start. If I find this incomplete, I'll throw you out. Or I'll set you on fire. I'll set you on fire. You put one piece of sodium on your pocket and that's the end of it. You pay all your fees, huh? किसी को नुकसान नहीं होना चाहिए. You can die, no problem. Pay your fees. Pay your fees. Huh? No, only one you write. The remaining I will do. That's my homework. Asking me the question. When a plate of food and tasty khana is kept in front of you, you ask me the question, which your plate always khana? Finish the whole khana now? Huh? Finish the whole khana now? Then why when it comes to homework, you have only one question to do and the rest of the question questions that we get for money.
Ma'am, if we don't like the food, it is.
Don't argue with me. I'm going to study like you.
You want money to buy chewing?
Don't talk. I want perfect silence. When you're doing your work, you have to concentrate on what you're doing. Shall I remove the board?
Yes, ma'am. Shall we also write the question?
Huh?
Shall we also
No,
write the
no.
question?
Number them and the page and write down from which textbook you're doing it.
Now, I'm in the formation of ammonium. Where are the
Ammonium or ammonia? What do you say?
ammonium NH4?
So
Where are
you
the
can't get ammonium. You can get ammonia.
no, when we form it? Where are the ions?
What do you want when you check me? Say ammonia, ammonium. You can't get ammonium.
Where we more medium?
Molecular with the formation of ammonia.
Where are they kept from the distance?
No, I don't understand. There is a converter, no? There is a converter in that nitrogen. Nitrogen is coming from one pipe, hydrogen is coming from another pipe, and then both of them are put under pressure and under temperature, and then they go into another container called the converter, and that's where they're getting converted. The interaction is taking place between nitrogen and hydrogen to form ammonia. And ammonia is collected outside into another container. So here there is one element in this container. And that can be done next year. It's ammonia, special chapters there on ammonia next year. If I'm teaching you next year, I will teach you next year. Well, it's still after Bombay.
Yes, she's here.
So she don't need to do something like that.
No, I'm not.
But she should have bruised there.
No, they're just classmates.
ENA result. Let me see how much you've done here. Let me see how much you've done. Here I'm giving you time to do your homework and you're playing the fool. You don't do the work at home, you're not doing it here in the class as well. Behave yourself.
Here's a question. State the conditions necessary for a chemical change or reaction to take place. So just you have to write the bullet points, right? Or you have to define
No, all bullet points and supporting your condition give an equation.
Yeah, example.
Balance the equation. Half a mark for condition, half a mark for example. 1 mark.
And every reaction is balanced.
Every
reaction is balanced.
Absolutely. It's an equation. Equation means right hand side is equal to left hand side. Yes or no? Then why do you call it an equation if it's not balanced? You know, I'm calling you Dada, you should be ashamed of yourself. You think it's a very big title I'm giving you. So shameless you are. If we were called Dadas in our time, we used to be so ashamed. We should just put our head down and not look at the teacher's face for the rest of our lives. You people think it's a title I'm giving you.
When we shake up soda water, does it pressure increase?
Pressure doesn't increase. You're agitating the gas. The gas has settled down. When you shake it, no, you're activating the gas. The gas has got its pressure. That's why it happens. The gas has your activity with gas.
So why does the liquid come out?
Huh?
Why does the
Because of the pressure.
Because it's
The gas is pulling up the pressure with it, with the liquid with it. Now, the gas is pulling that, or force of addition and cohesion. So then by each particle of gas is attached to a particle of water or the liquid, and it's pulling it out because of the force of
addition?
addition is unlike particle.
Oh, so
Cohesion is like particle. So addition. What is saying is addition. Gas and liquid.
It's like what happens when we boil milk.
Like when you boil.
The water in the milk is converted to steam, and then the steam which is beneath the
No. In the case of milk, the molecules of milk have got extra energy, so they're trying to escape, and they're pulling the milk out and overflowing the vessel. This is the energy that they're giving you. It's different. It's different. That concept is different. The more energy you give it, the higher the. You try to put up the stove, immediately the settle down because you're taking away the energy. But here, in the case of soda water, when you shake it, okay, and you keep it for some time, open it, it doesn't settle. Come out. There's no heat here. There's no energy here, except in pressure. Let's see which is what on the answers with this. There's nothing you wrote so far. Huh? Nothing you wrote so far. How much have you written down?
Sometimes there are sunlight and sometimes there are diffused.
Yeah. See, sunlight is direct sunlight.
Yeah.
Closest to the sun. Yeah, close. Yeah.
Direct.
Diffuse sunlight is sunlight coming from the sun to the atmosphere. See the layers of dirt, lithosphere, stratosphere, atmosphere. It's passing through so many layers, no? So that brightness is being reduced and it is diffused. Okay.
So to the
So that is
If only sunlight is like directly from sun
yeah,
without the layers.
without the layers. So you have to go right there.
It happens
That's
due to the reflection of light on that.
Pardon me.
It happens due to the reflection of light.
Refraction of light, because it's passing through various layers, the density of the layers is different. So the rays keep on getting reflected.
From denser to rarer.
From denser to
Rarer.
rarer to denser.
Rarer.
Yeah.
You only said that we used to keep our head outside.
Keep your head down.
No,
If someone called Gala.
stranger.
How many of you are there for English tomorrow? Okay, you're not there for English, you're not coming tomorrow. I want to see that homework done, okay? Otherwise, be careful.
You corrected that. Yes.
I will see it again.
Like you have to rewrite.
No, I'll see it. If I want, I'll see it. Okay, I can go now. And I want to see this homework, okay? I will throw you out. Next, first thing I will want to see this homework.
कौन निकल गया केमिस्ट्री वाला
केमिस्ट्री वाला इंग्लिश वाला वैसे
अच्छा दो नाम ही उसकी लास्ट नाम है इधर इंग्लिश मैं देखो कौन किया ये
केमिस्ट्री है ना?
ये
Patrick, why did you move it?
What?